welcome to this explainer. Okay, today we are going on a really fascinating journey. We're going to explore humanity's deep-seated drive to encode, process, and extract meaning from, well, unimaginably complex data. We're talking about a massive leap here, starting all the way back with ancient mathematically constructed mystical alphabets designed to map out the cosmos and taking it right up to the very pragmatic modern reality of artificial intelligence and edge computing. Ultimately, it's a story about how we structure reality just to make sense of it all.
So here's our roadmap for today. 1. Encoding the divine language. 2. Fractals and infinite patterns. 3. The cheap compute revolution. 4. Distilling knowledge in AI. And finally, 5. Digitizing the physical world. Let's get right into it.
How do we distill the infinite complexity of the universe into something we can process? Now, this right here, this is the fundamental question humans have been trying to answer for literally millennia. Whether we're trying to organize the pure chaos of reality using spiritual and esoteric symbols, or if we're crunching billions of parameters using silicon chips in some massive data center, the end goal is exactly the same. We're just trying to make the infinite manageable.
All right, Section 1, Encoding the Divine Language. Long before computers were even a thought, early thinkers were already attempting to build these ultimate logical architectures for human thought. Take a look at ceneezer. What's absolutely wild about the ceneezer system is that it doesn't just treat language as, mere sounds we make with our mouths. Not at all. It treats language as a rigid, almost mathematical framework. It's a base 31 system, meaning it relies on 31 fundamental symbols instead of our standard 26 English letters. And in this system, the numerical value mapped to a meaning matters infinitely more than what the symbol actually looks like. It's basically this incredible ancient attempt to take really profound abstract concepts, things like consciousness or the void or the literal spark of life, and force them into these neat, computable, highly logical boxes.
And you can see that ambition right here. Ancient sort of magical systems like this were actually attempting to bridge wildly diverse human cultures into one single unified structure. I mean, they were mapping English, Hebrew, Greek, and even runic alphabets all together. The sheer scale of that ambition is just staggering when you think about it. It's essentially a desire to create a universal protocol for human thought, kind of like how modern computer code acts as a universal protocol for our machines today.
So as you'll see, this mystical language operates on a strict, almost programmable visual logic. Just look at these symbols. That circle with a dot, it represents completion and unconditional love, and it begins every single word. But if you add a simple suffix like the negation symbol on the right, it acts exactly like a mathematical minus sign. It completely reverses the concept. So if you have a word for, say, hot, just appending that one little symbol instantly flips it to cold. It's literally highly efficient data compression just done with ancient symbols. And it doesn't stop there. Even a concept as slippery and complex as time itself gets distilled into this formulaic prefix system. Just by swapping out a single symbol at the start of a word, you mathematically conjugate the state of being. So you can categorize an event as forgotten or done, temporarily causing something, or eternal. They were basically structuring the fluid nature of time into hard, distinct data points.
Which brings us to Section 2, Fractals and Infinite Patterns. Because when we actually apply these concepts of rigid structure to modern coding, something genuinely beautiful happens.
Okay, let's look at this theoretical Python script. It acts as a sort of validation engine. By running a nested loop and calculating a mathematical index based on remainders, this script takes basic digits and maps them out to reveal a completely mesmerizing, infinite mathematical pattern based on the base of the numbers used. It's like a giant puzzle perfectly assembling itself.
Now here is where it gets really mind-bending. The source material ran this exact same script using English numbers, French, Arabic, Korean, Bengali, and Spanish. And you know what? Regardless of the human language or the specific characters that were plugged into the script, the underlying geometric fractal that generates on the grid behaves exactly identically, every single time. The specific symbols change, sure, but the shape of the mathematical truth remains perfectly preserved.
And this proves something absolutely profound about information. The underlying data structures entirely transcend the human symbols we use to represent them. I mean, whether you're writing in Greek or Korean, the math expands infinitely outward in perfect symmetry. The architecture of the data is what actually matters, not just the paint we slap on the outside.
Now, I want you to really think about this quote. In the age of cheap compute, the only thing that remains expensive and therefore valuable is unique data. This perfectly pivots us away from the theoretical, spiritual processing of mystical languages directly into the silicon processing of modern machines. We're officially entering an era where processing power is no longer the bottleneck. The bottleneck is the unique information we feed into it.
So let's jump into Section 3, the cheap compute revolution. We are bridging the gap from ancient, esoteric alphabets mapping the universe, straight over to NVIDIA GPUs mapping our digital realm. Welcome to the golden age of cheap compute.
We are currently sitting in this incredible technological sweet spot. Yes, massive hardware like H100 GPUs are still super expensive to buy, but the cost of actually running models, what we call inference, and fine-tuning them, that has absolutely plummeted. Thanks to highly accessible open-source models like Llama 3 and Mistral, processing massive complexity is practically free right now. We are quite literally doing things for pennies today that would have completely bankrupted a startup just 24 months ago.
Moving on to Section 4, Distilling Knowledge and AI. Because just as the ceneezer language distilled vast cosmic concepts into single, easily written symbols, we are now using this ultra-cheap compute to distill artificial intelligence itself.
And that brings us to knowledge distillation, which is arguably the highest leverage use of compute available today. Here's how it works. You take a massive, incredibly smart frontier model, like GPT-4o, and you have it generate mountains of high-quality training data. Then, you use that newly generated data to train a tiny, highly specialized model. You are essentially extracting the raw brain power of a trillion-parameter giant and stuffing it into a tiny, super-fast, free-to-run local expert that lives completely on your own machine. It's a total game changer.
And because of this, we're completely changing how we use AI. Since digital tokens are so incredibly cheap right now, we can afford to run what are called agentic reasoning loops. So instead of treating AI like a simple search engine, where we give it one prompt and just cross our fingers hoping for a good answer, we allow the AI to have a wasteful internal monologue. It writes a solution, tests it, finds its own errors, actually reflects on why it failed, and then rewrites it, over and over again, entirely automatically. And the results are staggering. By utilizing these iterative agentic loops, we push our output accuracy from a standard, somewhat unreliable 70% all the way up to an incredible 99%. We are quite literally substituting human mental effort with cheap, abundant machine compute.
We're even seeing this transition completely revolutionize biology and medicine. We're moving away from wet labs, which rely on expensive, really slow physical-chemical trials, over to dry labs. By using local compute and tools like AlphaFold 3 to simulate protein folding and how molecules bind to each other, scientists can test millions of combinations digitally for mere pennies. That is shaving literal years off the drug discovery process. There's no way we could do that before.
All right, final section, Section 5, Digitizing the Physical World. Let's look at how this architecture of information actually affects your daily life and your own data.
Think about all the unstructured dark data you have just sitting around. I'm talking about thousands of unsearchable PDFs, old emails, scribbled handwritten notes. Well, by utilizing the free compute that's just sitting completely idle in your M-series Mac or your PC, you can use OCR and multimodal AI to turn all that lost data into a vector-searchable second brain. And here is the best part. Because you're running small language models locally, your sensitive financial or medical data never even touches a third-party server. It is completely private and completely secure.
Furthermore, compute is now so cheap it's practically disposable. We can deploy tiny AI chips like an ESP32S3 or a little Raspberry Pi clone directly into the physical world. This enables Edge AI. Think sensors with real-time computer vision for your home security that can actually tell the difference between a delivered package and a stray cat, or acoustic monitors in factories that can literally hear a machine failing long before it actually breaks. We are bridging the digital and physical worlds with smart sensors that don't even need a human to watch them.
Don't try to build a general-purpose AI. Instead, use the cheap compute to curate, structure, and train models on niche datasets. The overarching takeaway from this whole explainer is exactly this. The winning move today isn't to try and boil the ocean. It's specialization. Structuring unique information is where the true power really lies right now. The big tech companies, they have the massive compute. But you have the unique, niche data. Curating that data is exactly where you derive value.
So, from ancient minds dreaming up the ceneezer alphabet to map the cosmos, to modern developers spinning up open-source models, the core human drive remains exactly the same, structuring the pure chaos of the universe into meaning. The tools to do this are now virtually free, and they're sitting right on your desk. So the only question left is the one right here on the screen. Whether using a mystical base 31 alphabet or deploying an open-source large language model, what unique data will you choose to distill?